Magic.
After taking temperature with two thermometers, it turned out that the electric one measures faster and more precisely, and everything is okay. Why do we still use archaic mercury thermometers? And what properties does this unusual liquid metal have? So, let's find out. Out of all the elements in the periodic table of chemical elements, only 4 of them can be in a liquid state under normal conditions. These are gallium, cesium, bromine, and mercury. The last 2 elements are extremely hard to freeze solid, because their freezing points are way lower than 0 degrees Celsius. Because of being extremely scarce in Earth's crust, it's extremely hard to find this liquid metal in nature. Few people have seen naturally occurring mercury near its deposits. This metal is mostly extracted from cinnabar, which is the most abundant mercury-containing mineral, which contains 2-valent mercury sulfide, such as scarlet chemical. Since the time of ancient Rome, cinnabar powder has been used as a scarlet pigment. If this powder is heated to a high temperature, cinnabar will break down into its components, which is sulfur and metallic mercury, which create a beautiful real mercury mirror on the walls of the container. Upon further distillation of mercury vapors, drops of this precious metal could be collected in the receiver. Because at room temperature this liquid metal made people experience undescribable feelings, since long ago mercury has been attributed with unusual and even mystical properties. Some even tried to cure different illnesses with this metal, whereas alchemists of that time wanted to create a so-called philosopher's stone, capable of turning any material into gold. However, all their attempts were futile, because this metal doesn't have neither any curable nor any other paranormal properties, and if it's not handled properly, it can even do a lot of harm. The thing is, when mercury is exposed to the air, it actively evaporates because of its abnormally high vapor pressure. This becomes evident when a drop of mercury is lit by ultraviolet light with a resonant wavelength. Entire clouds made of this metal's vapors can be seen on a luminescent screen. This vapor is extremely toxic and dangerous to people, as well as all mercury compounds. That is why this metal belongs to the class of extremely toxic and heavy elements. That is so because mercury ions easily interfere with the work of many enzymes, especially in brain neurons. Liquid mercury itself is quite a heavy and expensive metal, having a density of more than 13 grams per cubic centimeter. This container with 4 grams of mercury weighs more than 50 grams and costs about 80 euros. That's why this metal is a little bit more expensive than silver. If we take a look at the table of elements abundance in Earth's crust, mercury is located next to silver. Because of mercury's high density, some other metals may float on top of it, for instance this steel bolt. Even lead, which is known for its high density, floats on top of the liquid mercury, like a wood bar. Usually, mercury for laboratory use comes in rather big jars. The hand of our laboratory weighting scales almost went off the scale because of such a high mass, because this jar weighs more than 2 kilograms. From a chemical point of view, mercury strongly resembles silver. It also doesn't oxidize well in the air and has a high thermal and electrical conductivity. Besides, mercury also has an incredibly high coefficient of surface tension, which is why drops of this metal always take a round shape. This is exactly what makes this metal so treacherous, because drops of this metal can easily roll into some narrow spaces, and it will be extremely difficult to get them out of there. Because of having high density and having bad soaking properties, this metal was used in the first barometers, measuring atmospheric pressure, and also in thermometers. Nowadays, because of mercury's extreme toxicity and likelihood of shattering a mercury thermometer, such devices are actively substituted with electronic ones. That is why safety comes first. However, when reacting with certain other metals, mercury behaves differently to how it behaves on the surface of glass. For instance, mercury soaks the surface of copper-plated euro coins, creating amalgam, which is an alloy of copper and mercury. Thus, in a short while, you can turn a copper coin into a silver-resembling one, if you don't have a problem with the fact that it is plated with a layer of pure semi-liquid mercury. Usually, this method of creating an alloy of copper and mercury is used to collect spilled mercury drops, which easily stick to polished copper surfaces. Besides copper, mercury can also be alloyed with other noble metals, for instance with gold. For my experiment, I have purchased thin gold foil sheets. When a drop of mercury is placed on a gold sheet, it immediately begins reacting with mercury. When metals are stirred, the reaction runs even faster, and there forms an amalgam of gold and mercury. Depending on the ratio of metals, this amalgam can be either in a liquid or in a solid state. This way of dissolving gold has been used since the time of first gold diggers, who would dissolve pure gold powder in mercury drops. After this reaction, the alloy of gold and mercury could easily be separated with the help of nitric acid, because mercury dissolves well in nitric acid and gold deposits on the bottom. Besides reacting with noble metals, for instance such as gold, mercury can also be alloyed with regular aluminium. If we wipe aluminium with hydrochloric acid in order to remove the oxide layer and then apply mercury, the latter will immediately begin penetrating the aluminium bar, creating an amalgam of mercury and aluminium. Because of that, aluminium will easily begin oxidizing in the air, creating aluminium oxide, which will be deposited on top of the bar in the form of such a fragile substance. The leftover mercuric nitrate solution can be used for synthesizing an interesting compound, which is mercury thiocyanate. To do that, I am mixing the mercury nitrate solution with several drops of 10% potassium thiocyanate solution, and as a result, the reaction produces white mercury thiocyanate sediment. After filtration and drying, we get a seemingly unremarkable compound. That is what it looks like until it is ignited. When reacting with a burner flame, mercury thiocyanate ignites and creates a monstrous spectacle. Mercury thiocyanate has broken down into yellow carbon nitrate, formed by carbon dioxide and sulfur dioxide gases. When I touch this substance, it feels like foamed plastic. However, you should not dispose of it, because it is contaminated with vestiges of metallic mercury. That is why it should be disposed of a mercury-containing chemical waste. Mercury oxide is one of such toxic chemicals. For instance, over time, it slowly builds in old mercury barometers as a result of oxidation mercury in the air. However, in 18th century, few people know that mercury was toxic. That is why, in 1774, an English chemist, Joseph Priestley, decided to heat up this chemical and observe what will happen to it. When being heated up, mercury oxide began to break down into metallic mercury, leaving drops of this metal on the test tube walls, and there was also released an unknown gas. Priestley decided to collect this obtained gas into another container, and it turned out that this gas almost didn't dissolve in water. The scientist decided to see what would happen if he lowered a smoldering rushlight into the container filled with this gas, and it ignited. This is how oxygen was discovered, which was released when mercury oxide was breaking down. Until the beginning of 21st century, mercury was mainly used for making silver amalgam-based dental fillings. And in my next experiment, I am going to show you how to make a real mercury sponge. To do that, first we need to alloy mercury with an active alkali metal, such as sodium. According to the reference data, this reaction is supposed to release heat, but I could even have imagined how intense the heat will be. As a result of the sudden heating of the mixture and high thermal conductivity of mercury, the test tube didn't withstand the temperature difference and cracked. After collecting the content of the test tube, I had to continue the experiment. This time I lowered the test tube into a container filled with kerosene in order for it not to heat up so rapidly. After successfully alloying mercury with sodium, the obtained amalgam began to solidify at room temperature. If we add this substance to the test tube filled with ammonia solution, the alloy will only react with water, because the solution is still missing ions. But if we add hydrochloric acid to the solution, there will form ammonium ions in it, which will immediately begin reacting with sodium amalgam, creating a quite rare mercury and ammonia amalgam. This compound is unstable and quickly breaks down, forming vestiges of mercury and creating such an unusual sponge. If we add the obtained solution to the test tube with vestiges of sodium amalgam, there will show up a real mercury monster from the test tube. I don't know of any practical applications of this reaction, but for example, mercury and sodium amalgam is used in some organic synthesis reaction. After running my experiments with mercury, I decided to check if my laboratory was contaminated with accidentally spilled drops of mercury, which is why I made a mercury vapor indicator. To do that, I took a sheet of watercolor paper and soaked it in 5% copper sulfide solution. After that, I sprayed it with 10% potassium iodide solution, and there formed dark iodine spots and also white copper iodide spots on the paper. In order to improve the indicators, I dissolved the dark iodide spots with 10% sodium thiosulfide solution. After that, I rinsed the paper sheets off with water. When the paper sheets dry off, I'll have ready to use mercury indicators, which will become orange if there is mercury. Transition time will depend on the concentration of mercury in the laboratory. But nowadays you can even purchase special copper iodide based tests to test your room for mercury vapors. In the end, I decided to encase vestiges of mercury in an ampoule for storage, because even in a tightly sealed jar there may be still a leakage of this metal's vapor. So I think after viewing that video you will know more about this liquid metal and its properties. And if you like this video, don't forget to give it a thumbs up and subscribe to my channel to see many more new and interesting. And also I want to say thanks to the Onyx Med company who provided me some reagents for this video. I'll put a link to their site in the video description.